Hello, we are going to be doing graphing some functions today. So I will start graphing a linear function, then a quadratic function. Here I have my equation y equals 2x minus 5. With a linear function, I have two parts that I need to identify. First of all, I need to identify the slope of my function, or what we call the rise over the run. How much my function will increase, how much y will increase when x increases by 1. If we look here, we see that for every 1 x, y will increase by 2. That's my slope. So for every increase on the x by 1, y will increase by 2. I go up by 2. And I also need to identify the second part, which is the y-intercept. And the y-intercept, simply put, is where your function will be intersecting the y-axis. And that's the second part in this function, which is negative 5. So with these two pieces of information, I can go ahead and graph my function. If I take my x-axis, as you can see, and the y-axis here, I have 1, 2, 3, 4, 5, and the y the same. Let's graph first the first one, which is the y-intercept. So I need a negative 5 on the y. Negative 1, negative 2, negative 3, negative 4, negative 5. That's my point. That's the first point I will need. Second one, which is the slope. We said our slope is 2. So for every increase by 1 unit in x, y will increase by 2. So let's say x is increased by 1. So in this case, what will be the y value? Y will increase by 2. That's a point. If x increases by 2 values, 2, then y increases by 4. 1, 2, 3, 4. I am here. And it's enough for you to just have 2 points to graph a line. But if you want to go ahead and do the rest of them, okay, we see that the step is going actually by 2. So by 2, 1 by 2. So that will be landing here. 1 by 2, that will be landing here. 1 by 2, that will be landing here. If I am to connect these points, I will be making this line, which is y equals 2x minus 5. The second part is how to graph a quadratic function. Graphing a quadratic function, that's a parabola. Look at your parabola here. This is my equation, y equals x squared minus 3. I can opt out to use a table of values. So I will be starting a table of values here, x value, y value. And I would like to go with negative values on the x-axis and positive values on the x-axis as well. And here is my y values. Each one will be 1. So at x equals, say, negative 2, what will be the y value? If I apply that here, so that will be negative 2 squared, which is a 4, take away 3, that will be 1. If I have x equal negative 1, so basically I am putting here negative 1 all squared minus 3. Negative 1 all squared will be positive. 1 minus 3, that will be a negative 2. When I take a 0, 0 take away 3, that's negative 3. When I take a 1, so that will be 1 squared negative 3, that will be again negative 2. When I take a 2, that will be 2 squared, which is a 4, take away 3, that's a 1. You see there is symmetry around this point here, which is 0 and negative 3. So let's decide on the 0. 0 is here, negative 3, 1, 2, 3. That's what we call my vertex. So that's a vertex, or the lowest point on my curve. Then at x equal negative 2, that's this point, I have y equal 1. This is it. At x equal negative 1, I have negative 2. So negative 1, negative 2. This is my point. And because I have the symmetry, so when it equals 1, I have also negative 2. When it equals 2, I have a 1. If I go ahead and connect to my graph, this will be what I will get. That's my quadratic, and it will go this way and that way. As for my linear function, it also, I need to say that it will be going both ways. Quickly, what's the domain and what's the range? Domain, which is the x values that x can take. Here, x doesn't have any restrictions, so I'm gonna say x is element of real. How about the range or the y values? Y can be anything as long as it's higher than or equal to the -3. So that's a restriction. So I will say y element of the real, and y has to be greater than or equal to -3. So that's deciding on my domain and on my range. Thank you for watching. If you like our tips, please subscribe to our channel. Have a great day.